Hello students, today is our topic Riemann sphere and point at infinity. Riemann sphere and point at infinity. Point at infinity. This is a topic of real analysis. Very important topic. So let's start to watch this video. And before we start, I also tell all of you to subscribe this channel if you have not subscribed. If you like this video, then like, share with your friends, and if you have any suggestion, then comment me. Any complex number z equal to x plus iy can be projected can be projected by a sphere, unit sphere, projected by a unit sphere and also through this and through this we can define point at infinity. Point at infinity. So how it can be described? I draw a sketch path to represent the Riemann sphere and point at infinity. So let's watch this diagram. Here I've taken a 3D plan. 3D plan. This is the origin. So this is x-axis, this is y-axis, and this is z-axis. Now any unit sphere can be drawn in this way. This is unit sphere. So it is a unit sphere. The unit sphere. It has also a vertex. at the point at the point 0, 0, 1. This is the point 0, 0, 1. This is denoted by V vertex, and this is our x. This is our xy plane actually. I would normally this will be z, and this is y. So now on the xy plane there is a complex number. This is the plane xy plane where any complex number is defined. J equal to x plus I1. So we wish to represent the complex number through any point on the sphere. So you can do this if we take a point A. This is the point A. Coordinate on the rectangular coordinate is x, y, z, and and its projection to the xy plane. If we wish to establish the point Z, so we will draw a straight line from the point B to A straight line point A which touches the xy plane at the point A slash, and its coordinate will be x, y, 0. Now this is the complex number. This is the complex number actually z. This is the point z. So this is the z point in the xy plane. So each of the point on the sphere can be represented on the xy plane through any point on the sphere. So every point on the sphere can be represented on the xy plane, which is a complex number on the xy plane. Now we wish to know the relation between the points V, A, and A prime. So you know that that by 3D and geometry 3D we know on a straight line any two points can be joined by a relation. If we have 2 points P and Q, coordinate are x1, y1, z1, and Q is another point represented by x2, y2, z2. Then any point on the joining of the PQ R, which has a coordinate x, y, z. Then the equation of the straight line will be x by x1 by x2 minus x1. Then equal to y minus y1, y2 minus y1, and z minus z1 by z2 minus z1. We use this equation form in this straight line VA dash A slash, and we will get in this way. Through this equation of straight line we will get x minus 0 by x equal to y minus 0 by y and z minus 1 by here will be actually 0 minus x minus 0, and there will be y minus 0, and there will be 0 minus 1. So we have the relation uh, x by x equal to y by y and z minus 1 by minus 1. From this we can calculate x will be, from here x we can write that it will be x minus 1 minus z, and y will be y by 1 minus z. So now any complex number uh, uh, can be represented by a unit sphere, unit spheres point. So any complex number in a xy plane can be represented by a unit sphere point, um, any point xyz. So this is our complex number xy coordinate, which is represented by a point on the sphere. So this is called stereographic projection. This is called stereographic projection. Stereographic projection. Now we will find out some relation projection. So here z can be written right down x plus iy, and it can be represented by any point on the unit sphere in this way: x plus iy by y minus z. Now, if we conversely wish to represent the point on the sphere through the points of the complex number, how we can represent? In this way, we can represent this. Use this is a unit sphere, so there will be a relation x square plus y square plus z square is equal to 1. And the plan xy plan, the equation we have z equal to 0. For the complex plan we have z equal to 0. So if we use these relations, then we will get x is equal to 2x by x square plus y square plus 1, which will be equal to z plus z conjugate, and here mod of z square 1. So if y can be represented, then it will be 2y by x square plus y square plus 1 equal to, this will be z minus z conjugate mod of z whole square plus 1, and the point z can be represented in this way. The point z can be represented in this way. Z will be x square plus y square minus 1 by x square plus y square plus 1. You can verify this result. Just very easy to find out this. This will be mod of z square minus 1 and mod of z square plus 1. Now we find out that except the point z vertex of the unit sphere, every point, because you can look this, that z cannot be equal to 1. So at the point uh, V, the vertex of the unit sphere, all the points have a projection on the complex plan. So here we have a definition of point of infinity, that where the projection of the vertex lies. So point of infinity in the complex number can be defined now through this Riemann sphere or steographic projection in this way. So if we take z equal to 0, z equal to x plus iy equal to 0, if this is 0, through this we can write down that x equal to 0, y equal to 0, and z is equal to minus 1. So x0, y0 and z equal to minus 1. So if you, now again I am drawing this unity sphere. If you follow this unity sphere's vertex, this was 0, 0, 1, and at this point this is 0, 0, minus 1, 0, 0, minus 1. So so if we will take the conjugate of z, z conjugate of z, will be 1 by z. So when z equal to 0, then the conjugate of z is lies point at infinity. It corresponds with point at infinity. When z equal to 0, it's like the point lies, the conjugate lies corresponding with the point at infinity, and it is in the Riemann sphere. It can be represented by this point 0, 0, minus 1. So if we will take in the reverse way, that z is equal to 1 by z conjugate, then transformation also give us and j conjugate is equal z conjugate is equal to 0, then j corresponds to the point at infinity, and this point it can be represented in the Riemann space by 0, 1. So in this way, any point at infinity can be defined in the Riemann sphere or stereotype projection. So in the complex band, the point at infinity also can be defined by the Riemann sphere. So we have a complex band with can be extended up to infinity, but up to infinity all the points of the complex band can be defined by Riemann sphere. This is the importance of the historiographic projection. So thanks.